Welcome to another episode of the Mapscaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is Vikram Vindetti. Vikram is a distinguished engineer at a company called Foursquare, and you'll learn later on in this podcast episode exactly what that means. But for now, it's important to understand that this episode is focused on spatial knowledge graphs. I've been working with Foursquare over the last couple of weeks to produce a mini-series of episodes, and these episodes all tie together, and you'll find links to the previous episodes in the show notes of this one. So without further ado, let's dive in. Hi Vikram, welcome to the podcast. You have this amazing title. You are a distinguished engineer at a company called Foursquare, and today we're going to be talking about all sorts of interesting geospatial stuff, possibly focusing on this idea of geospatial knowledge graphs. But I think before we get there, can you please introduce yourself to the listeners and tell us what it means to be a distinguished engineer at Foursquare?
Hi, Daniel. First of all, glad to be here. I joined up Foursquare about a year ago, and I'm still figuring out what that title means. I report into the SVP of engineering and have been focused primarily on evolving Foursquare into a true location platform, in some sense, geospatial platform in some sense. And I'll talk a bit about what that means as we go through the podcast. But prior to joining Foursquare, I was with Amazon for about 15 years. And I was fortunate enough to be the first engineer on the Alexa voice assistant team and got to ride the entire voice assistant wave. I didn't have any geospatial experience joining before joining Foursquare, so it has been an exciting ride for me.
So what was it like? What was it like learning geospatial or discovering that, there's this thing called geospatial and now I have to learn to work with it? What were the biggest hurdles at the start?
I don't know if there are two things that came predominantly to me as I was ramping up on this space. One is, as an outsider, I always associated geospatial tech with mapping and routing applications. But when I joined Foursquare and I learned more about the applications of location data, it spans a broad spectrum of industries, whether you're building location experiences within your app to help your consumers make a decision, or whether it is businesses like Starbucks trying to plan a new location, store location, or Amazon trying to put up their new locker location. All of those require location data. So that was the first insight about the application of the space itself, or like applications in the space itself. And the second thing was that the reason I felt like we don't hear much about geospatial outside of a certain circle is that there is a steep ramp up to this space. They're very specialized tools, specialized technologies that one needs to be ramped up on or like built into their infrastructure to derive meaningful insights from the location data. So I had to go through that. So those two things came as interesting insights to me as I ramped up on this space.
What's your focus at Foursquare? What are you doing there? Because you came from this amazing position at Amazon, working on the Alexa voice assistant, and with as you just said, very little experience working with spatial data. And you joined Foursquare, which is a spatial data company. What is it that you're doing there?
Yeah, so I think Foursquare as a company has an interesting evolution, right? Like it was a consumer app company back in 2015, 2016. It was one of the most popular social apps. Then Foursquare pivoted to enterprise, becoming one of the leading providers of points of interest data and movement-based insights to our customers. And then eventually, Foursquare also acquired a visualization company called Unfolded, which is now packaged as Foursquare Studio, and we have some interesting products in the advertising space as well. But as a result of these acquisitions, all of these are in different silos, if you were to, and each product has is built as a vertical. What I'm focused on in Foursquare is like how can we compose all these assets into a unified technology platform on top of which we can build multiple applications on. And what that means is like today we have places data. I'll give one example of places data and visits data, right? Like, and they're loosely coupled in some sense that the visits data depends on the places data. But for our customers using the visits data, they need a lot more insights. So they have to spend a lot more time to derive insights about visit data. I'll take an example. If you're using Redfin and you want to purchase a home, what kind of insights do you want? You want to find out like, hey, where are people living in this neighborhood? Where are they typically working? Where are they spending their time? What are the popular restaurants these people go to? And those kinds of insights, gleaning that today from our data, it takes a lot of time. And it's not just our data. Any company that is doing in the location space, you have the data, and in deriving insights from this data takes a lot more time. And one of the problems we are trying to solve through our efforts in this geospatial platform and the knowledge graph, which I'm going to talk about, is reducing the time to insights from geospatial data and help businesses focus on how they can use those insights to make better business decisions.
So this is not a critique at all, but I mean, I hear this a lot, right? Reducing the time to insights, making things easier. Sometimes people use the word democratizing, but I think when you boil it all down, it comes to making this easier. Like what would this look like if it was easy? Tell me more about why it's so difficult. Why is it difficult to get the insights out of all of this data that, not just Foursquare, but everyone seems to be collecting? In your with your understanding now, after a year working in the space, what is it that's getting in our way?
I think it boiled down to, after spending some time on this, it boiled down to two key things as to why it is difficult to, or why it takes a long time to get insights out of geospatial data. One is you need to aggregate a lot of data sets and join them together. For instance, even in the example I said about Redfin, you need to have neighborhoods data, you need to have information about users' home locations, you need to have information about their user, the visits data, and you need to join these in different ways and aggregate them in different ways to be able to derive some of the insights I talked about, right? So aggregation of different kinds of data is one problem. The second one is the joins themselves are not easy. Like joining data itself is not easy. The attributes typically, because in the geospatial space, one of the things I've learned is like you join based on geometries. And what I mean is like a neighborhood is represented as a polygon, point of interest is represented as a point, and a route is represented as a line string. And you need to do these complex spatial joins, and you need to join multiple of these data sets, and that's where the complexity increases. So you need specialized tools now to do the spatial joins. You need to have a lot of infrastructure aggregating all this data to be able to do those joins and derive insights. So as a result, the time to deriving value out of this data increases. And companies often, even though they have some chunk of the location data or some aspect of the location data, because they need to invest in acquiring all these data sets and building up this infrastructure, they often shy away from deriving value from their own location data.
What does that mean for Foursquare in terms of like creating new products? Because you make it sound painful, like joining all these different data sets, and it makes sense that we join it based on location. What else? There's probably no primary key here in the data set that's going to link all these things. So let's join it based on location. This makes sense. But what does that mean for Foursquare at the moment in terms of making new products? Is it a question of making, for every new product, we need a series of new tables, maybe new views, that kind of thing, before we can roll out a new set of products that provide insights to people?
It's primarily organization of data. How do you organize all the data? Like for instance, for places, for a points of interest data, we use roads and buildings to and build models on it to determine, to improve the accuracy of the lat longs associated with that place, right? And if you want to use the same roads and buildings data to improve our visits models, it's a yet another pipeline that we need to build and join the data in a different way to be able to improve the accuracy of our snap to place models, right? So it goes down to the point of, again, acquiring more data sets and joining them in a way and accessing them in an easy way so that multiple teams can benefit at it at once, right? And we have looked at this problem, like over the last year we looked at it, this problem, as to whether there is any different way of solving this. And we found two emerging technologies that were of help, and we are building a solution based on that. One is the H3 grid system. H3 is a hexagonal hierarchical grid system. Every segment on Earth maps to a hexagon, and smaller hexagons are contained in larger hexagons, and there are up to 15 resolutions of hexagons covering the entire Earth. So one is the H3 grid system. It made using H3 to index all our data sets made it easier to access the data. I mean, that means that like every data set, every data value, every POI or a visit or the home location of a user can now be mapped to H3. But also, even admin boundaries like neighborhoods, cities, counties can also be mapped to H3 cells. And that made it easier to aggregate or join different data sets based on the H3 cell IDs. The second technological innovation or emerging technology is graph technologies. So as I said, like one of the things is like we want to be able to join different kinds of data sets, and sometimes insights come from joining data sets that are multiple hops away in a graph. And there has been an emerging trend around graph data sets we have been able to leverage and organize our data, all our data and relationships in the form of a graph, while using H3 as the unit for anything that ties to a location.
Would you mind giving me a sort of brief understanding of what H3 is, the H3 grid system?
H3 is a hexagonal grid system representing every segment on the Earth. Any portion of Earth is mapped to a hexagon, and hexagons are hierarchical. Smaller hexagons are contained in larger hexagons, and there are up to 16 resolutions of hexagon. The smallest hexagon is about a square meter in area. The H3 grid system has some unique properties. The centroid of a hexagon is equidistant from all its neighbors, and this leads to some interesting properties from indexing of data perspective. It leads to evenly spaced assignment, even assignment of data points, making it more compact. And for any algorithms involving traversal, we can treat all the neighbors in a similar way because they are all equal distances away, and you don't need to have special treatment for different kinds of neighbors.
So you've mentioned this idea of a knowledge graph a couple of times already during the conversation, and I wonder if we could focus on that for a second before we move on to the geospatial side of it. So my understanding of a knowledge graph is that it's made up of nodes and edges. If we think about Foursquare, for example, the nodes might be people and places, and the relationships between those two things, and I'm sure a lot of other things, are edges. That's what I know about knowledge graphs. Could you expand on that for us, please?
Yeah, a knowledge graph is a network of relationships between real world entities. It bakes in the semantics of the relationships. For instance, in our case, even in the Foursquare case, people have a relationship with a place. It could be their home, it could be their work location, it could be the restaurant they frequent to, or it could be the neighborhood they're living in. Even just between people and places, there are different kinds of relationships that could exist. And that place itself could have information about it is part of a mall or it is part of an airport, and it is part of a chain, right? Like it is a Starbucks, it's a part of the Starbucks chain. Representing all those relationships in a network or a graph like representation is what we are trying to achieve with the knowledge graph.
Those relationships, is that something that's calculated, that you run a function over it and calculate those relationships? Or is it something that's discovered as you traverse the graph from node to node?
So some of these are computed, some of these are discovered on the fly. Like some of these are computed, or we do apply our own models to understand. Like for instance, part of our places engine, the engine through which we generate our points of interest data, we also build associations to chains, right? Like this location is part of this chain. So some of this comes through as part of our ingestion processes themselves, but some others, like people who are going to this store also go to this store after this, right? So that is kind of like a discovered or computed relationship, like likely to visit this store after this store. And some of this is pure graph traversals, right? Like I have the location of a person or the residential location of a person. That point happens to be associated with a neighborhood. So now I can infer this person is living within this neighborhood.
How do you compute the strength of these relationships, like between these different places? So, I leave for work every day, as a thought example. I leave for work every day. I have a strong relationship to my house and to the place that I work. But how do you compute that? And how do you compute the likelihood of someone like me, like going to work as an example, and then going to a certain shop afterwards? So I'm really interested in how you know how strong the relationships are between these different nodes on the graph and the likelihood of an edge between different nodes.
I think some of these are machine learned models themselves that we build. Now that we have access to information about Daniel is spending X amount of time in this particular location, and certain attributes of the location make it a work location, and we assign a probability to say that, like, this is most likely Daniel's work location. You are using the raw data in the graph and computing some of these new edges or relationships by applying models.
Do these edges, are they fluid? Like, do they change? Do they disappear over time? Do they evolve, or are they set?
We keep updating those things, some of the computed edges, computed relationships. they get updated every time. And even our points of interest data, new places get added all the time. So we keep adding, updating our graph on a regular basis. And the other thing is also the temporal dimension of this. We not only means we have a live copy which we are updating with newest information as we have new data coming in, or our models run and update some, compute new relationships which get added to the graph. But we also take temporal snapshots at different points in time to understand change patterns over a period of time.
So we talked about the nodes before, and in my example, they were people and places. I'm sure they could be a lot of other things as well. And I also mentioned this idea of geospatial knowledge graphs earlier in the conversation. Do those people and places, do they have to have an XY coordinate attached to them to be a geospatial? Are they just in the fact that they have this relationship within the graph, does that make them spatial? I guess what I'm asking in a very clumsy way is, can you explain to me how we add the geospatial element to these knowledge graphs?
The geospatial element comes from like the fact that a lot of information in these data sets that we have has a location attribute, and we are taking the h3 grid, flattening it, or like exploding it into a tree in the hierarchical relationships, and attaching our data to those h3 nodes at the appropriate resolution. So for instance, a neighborhood which is a boundary could be at a higher resolution like h10, but the point of interest could be at an H14 resolution. Now, you can know containment relationship at this point, like this person lives in that neighborhood. Another example is, let's say you have weather data. There are weather polygons for which units at which the weather forecast data is coming in, right? Now, I can map that to H3 cells. Now, as a result, I can understand, like, for instance, someone like Uber, they can understand, hey, the weather forecast at this location or this H3 cell has an impact on demand surge, right? And by way of indexing all this information to a location, and by location I mean the h3 cells, we are able to infer correlation and causality between different features or different attributes.
Wow. It's a lot to take in. Like I'm not an expert in this, but in any way, shape, or form. But I think I understood before when you're talking about, how things can change over time and your way of dealing with that. But what you're saying here is that you could take a very fluid factor parameter like weather and add it into this and update it on a regular basis. And you could see changes in the relationships between the nodes based on this on a parameter like weather.
Yeah, I think it's two things, right? Like especially as climate science evolves as well, you want to understand how the patterns are changing over a period of time, and also how, from a ride share or other perspective, like if it is going to rain, is that going to cause a rise in demand for cabs, right? Like I think that's those are use cases that this could enable.
This might sound like an incredibly naive question, but why haven't we been using knowledge graphs all the time? Like this sounds like a great idea. Instead of joining data in all these archaic ways, spread across thousands of tables and queries and joins and views and all this kind of stuff. Why haven't people been doing this, right from the start?
That is a question I've been asking. But I think, again, as I said, there are some use cases where precision matters, right? Like, and there are some use cases where it doesn't. And I think my naive assumption is that when this whole space is quite old, and it started with applications where the precision mattered, and we are venturing into more and more applications where precision is less important, but the ease of access trumps precision in some sense, right? Like, or the margin of error that is caused by using a grid system like H3.
Yeah. H3, in my understanding anyway, deals with everything in aggregate. We're aggregating everything up to the level of these H3 cells all the time. So it's not, we can't deliver a precise polygon to you. I might be saying this in a very clumsy way, but we're taking all data, and it doesn't matter if it's raster, point, polygon, whatever, and we're turning it into a surface of these H3 cells. So everything is dealt with in aggregate.
Yep. I wouldn't say everything is mapped to an H3 cell and information is stored at an H3 cell level. Like if a polygon is mapped to a set of H3 cells, and you're distributing that information associated with that polygon to all the H3 cells in some sense.
Okay, so I could actually return precision data if I wanted to.
I mean, the mapping from polygons to H3 cells again has, like, you're going from a precise representation to a lossy representation. So if you go back, then you are actually go back, you'll lose some precision there.
So thank you very much for helping me understand knowledge graphs and especially geospatial knowledge graphs and how you're using them. When you think about the organizational structure in Foursquare today, is managing data in this way going to be easier, like going forward, when we think about moving away from these spatial drawings to a graph structure? Like I understand that it makes a lot of it, unlocks a lot of potential in the data, but does it also make it easier to maintain?
Absolutely. I think one of the things we have created, and again, most of these started as internal problems we were trying to solve that also resonated with a lot of our customers, is that by having a central place where anyone can access all data and continue to add data sets into that central location has helped, again, in a true sense, like democratize access to all the spatial data sets we have. Like, for instance, we have demographics data sets that are at census blocks levels, right? Like, and now earlier, when three teams required that data, they had to build custom pipelines to ingest it into their own pipelines, right? And now it is all available in a single location and accessible in an easy way.
Right at the start of the conversation, you talked about making Foursquare like a true location platform. Once you've done this, once you've migrated over to these knowledge graphs, will you be a true location platform then?
Yes.
Good answer.
Yes, absolutely. The idea is that, like, once you have the strong backbone, which is a knowledge graph, you can unleash a lot of applications and serve the needs of different personas of our users, like whether it is a developer, an analyst, it's scientist, or someone using our visualization tools. The data becomes accessible, or someone developing apps. All those will be built on top of this common foundation, and that is our definition of a platform, at least.
How will they know? Like, will they feel any difference? Will they notice any difference, or will they just access data in the same way they always have through APIs? Or will is it going to be more flexible? Can they ask different questions and different queries towards the database? Will the end user notice a difference? I guess is what I'm asking.
I think they will notice a difference in different ways. One is our existing customers will see that the quality for existing products gets better because our products internally have a lot of access to data sets which could improve their products.
Well, hold on. What does that mean? Gets better? Like, will they be more complex queries? Will they be able to rely on the data in a different way? What do you mean with it?
One example of our products getting better, right? Like, for instance, in a points of interest system, one of the biggest things that our customers always ask for is like reducing the time to discovery of real world places, right? Now, identifying that is very difficult, but if we have information about where people are stopping, right? And if we have we can now use that information to understand where there is a change pattern in where people are stopping, and if there are new locations that are coming up, and then we can go and do concerted data collection in those locations to identify new places. That's one example. And our snap to place model, which given any lat long identifies which place a user is at, now also has awareness of the spatial context like roads and buildings. And if the user is within a building and is on a certain floor, then this is kind of the POI that they may be visiting. Those kinds of improvements can be driven to our existing products.
So this is something new for Foursquare. When you showed up from Amazon and said, "Hey, we're going in a totally new direction," what did people say?
We started working backwards from some of the problems, and there was a healthy skepticism. And the question that always comes up is like, why hasn't someone else already done this if this is so obvious, right? And so we at least laddered it up to the way we approach this is making sure that, like, first we solving some internal problems so that there is a proof or there is a validation of that this approach makes sense, and then now going big on solving our customer problems as well.
Okay, so now that we understand a little bit more about knowledge graphs and especially geospatial knowledge graphs and what you're doing at Foursquare, all this begs the question is what is possible now? So what questions can we answer now that we couldn't answer before? What does this enable for people?
I think the biggest value add of the knowledge graph and how we are representing the data and making it accessible is not that these answers were not answerable before. It just makes it a lot easier to answer those questions because you have all this data pre-joined in somewhere. And what I mean by that is, like, let's say you want to answer like an example of what are the popular restaurants visited by people working in this location. Where do people working in this location go for lunch, right? We could answer this question today. It just requires first understanding what are the work locations of users, joining that with the restaurants in the work neighborhood, like taking the restaurants data set, places data sets, filtering by categories, joining it with the neighborhood so that you are only looking at the neighborhood restaurants within that neighborhood, and then answering and computing the visits corresponding to that. By our way of organizing this data in the graph, all of this could be answered through a simple traversal. Like, we could go from start with a neighborhood, identify all the users for which that neighborhood is a work neighborhood, and then identify all the restaurants that are mapping to the same neighborhood, and look at the visits counts from these particular users to those neighborhoods. So it's a series of graph traversals that will answer that query. And because we have already organized that information in that form, it makes it easier to ask those questions. Otherwise, you would have ended up with doing spatial joins and very expensive spatial joins to answer the same query.
Solving it with a graph sounds like something that can be done on the fly. I can just show up tomorrow without warning you I'm coming and ask this question, and you can give me the answer. And my guess is currently I have to tell you this is a product I would like, this is a query I'd like to be able to run, and you would have to go and organize the database in such a way that that I could get my answer when I ask that question.
That's a very crucial point, right? Like, a lot of times our customers don't know what questions to ask. And when they come up with the question, we can immediately translate that into something we can answer on top of our infrastructure now, on top of our knowledge graph. Earlier, somebody has to say, hey, this is the question worth answering. And then you spin up the infrastructure to answer that question.
Do you talk to your customers about a knowledge graph when you're, selling this or communicating it? Do you say we're moving to a knowledge graph, or do you just say this is possible now? We've got a more flexible system.
I think we are taking a two pronged approach. Like, one is we are talking to our customers to understand what use cases we can solve for them using a knowledge graph, and there are a lot of them. And the other one is, like, we are now enabling interesting use cases or interesting attributes on top of our existing products themselves, or interesting groupings of our existing products. That flexibility did not exist. Like, for instance, today we sell our places data. You sell by state or by country or worldwide, right? Like, that's the granularity we have. And now if somebody wants to do an analysis on New York data, right, like, it makes it very easier for us to just get that subset and give it. Or if somebody is only interested in malls and airports data, right, like POIs and malls and airports, it becomes very easier for us to package that data and give it to them, rather than having to buy our entire data set and wade through what is relevant for them.
Oh, that's interesting. I never thought of it like that. So what you're saying is that the knowledge graph approach or structure makes it easier to be more flexible with the kinds of queries that you ask, because it's in the graph structure, traverse the graph, find the answer. But you're also saying it makes it easy to tease those data sets apart and pull out and give them to someone in very specific data sets, as opposed to like you need the entire table.
Yeah. And I think the interesting part with that is that as we augment the knowledge graph is going to become very huge as we add more and more data sets. All our customers won't be interested in the entirety of that data set. So we want to be able to package what is relevant to them and give it to them in a format they would like.
Wow, there's a lot to take in, but it sounds amazing. Where else do you see knowledge graphs being used today? Perhaps this would be a good idea to talk a little bit about this. Give the listeners an understanding of that this isn't something that just Foursquare is doing. Maybe you could give us some examples of other knowledge graphs out there that we might already be using today.
I think IMDb is a good example. It has the movie knowledge graph, like, the filmography of which cast member is in which movie, or they use that, like, they have exposed a graph API which can be used to answer interesting questions about films in general, or any films or TV series. That's one example of a knowledge graph that comes to my mind.
We often hear about social graphs. Is this just another name for a knowledge graph?
Yeah, social graph is a knowledge graph with person as the central identity, right? Like, an individual as a central identity. In our case, the location is the central identity around which we are organizing all our information.
Vikram, I know this is the first time you've ever done a podcast episode, and I think you've done an amazing job. So I think probably now is a really good time to round off the conversation. And I just want to say thanks. Thanks very much. I've learned a ton about knowledge graphs, geospatial knowledge graphs, and the way they can be implemented, or maybe not implemented, but like the potential of them, I guess. Fascinating conversation. I really appreciate your time. There'll be people listening to this that think, wow, how can I learn more? And where can they go to do that? If they want to reach out, if they want to learn more about knowledge graphs and the kind of work that you're doing, where can they go to do that?
People can visit location.foursquare.com and all the information will be available there.
Wonderful. Thanks very much for your time. And I have to say, for your first podcast, you did a brilliant job. Well done.
Thank you. Thanks a lot, Daniel. I think you've helped a lot in filling in the gaps.
I really hope you enjoyed that episode with Vikram. As I mentioned in the introduction of this episode, this is part of a mini-series that I'm doing with Foursquare. We've covered a variety of different topics, or a couple that were mentioned during this episode, which you might find interesting, are the H3 system, so the H3 tiling system. There'll be a link to that in the show notes. There'll also be a link to the first episode I published with Foursquare, all about points of interest data, and I think that'll add a lot of context to this discussion as well. On a slightly different note, I've published an episode before with a company called Unstruct Data, and they were looking at unstructured data, as the name suggests, and then building this a relationship graph in the background to help people sort of discover the information that I guess they already have. So I'll put a link to that in the show notes as well. I think it's again, it'll help add context to the conversation you've just listened to. Okay, that's it for me. Thank you very much for tuning in all the way to the end. I really appreciate it. I'll be back again next week. I hope that you'll take the time to join me then.